Hello students, welcome to today's lesson. I'm teacher Alice and we are looking at the chapter 3 of Form 3 Chemistry, and the topic is Organic Chemistry 1, and we introduced this lesson in our previous lesson, and so today we are looking at part 2 of the topic, and we are going to start with the first hydrocarbon that we named as alkanes. Remember, we said we have several types of alkanes, starting with the several types of hydrocarbons, starting with the alkanes, alkynes, alkanols, alkanoic acid. So today we look at alkanes, and we said that alkanes are saturated hydrocarbons, meaning they have only one single bond between carbon atoms, and the first 10 alkanes we named them. We said we have methane with one carbon atom, ethane 2 carbon atoms, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, according to the number of carbon atoms. That is how we name the alkanes. Okay, so we have the alkyl groups. When we remove one hydrogen atom from an alkane, we form an alkyl group. For example, if we have methane, so methane has 4 hydrogen atoms. So when we remove one hydrogen atoms, we are going to have 3 hydrogen atoms and 1 carbon atom. So that one will no longer be methane, but it will be what we call a methyl group. So that one is not a methane. For example, also if we have an ethane, ethane has 6 hydrogen atoms. If we remove one hydrogen atom, we are going to have 2 carbon atoms and 5 hydrogen atoms. So that one now is what we call an ethyl group. So ethyl group is from ethane, methyl group is from methane, propyl group is formed when we remove one hydrogen atom from propane, and butyl group is an alkyl group that is formed when we remove one hydrogen atom from butane. So this is how we form alkyl groups, and we remove the suffix a and e and we replace them with yl. So an ethane becomes an ethyl, and so on and so forth. So let us look at the isomers of alkanes. And before we look at the isomers of alkanes, we start by understanding what are isomers. So we define isomers as those compounds with the same molecular formula but different structural formula. So in the first lesson of this chapter, we looked at the difference between the molecular formula, or what we call the general formula, and the structural formula. So if compounds we have different compounds with the same molecular formula but different structural formula, we call these compounds isomers. Then we have the other term we refer to as isomerism, and we say that isomerism is not just the formation of isomers. So you might be told to define or to give the definition of the word isomerism. Most of the students will say it is the formation of isomers, but we say that isomerism is the existence of a compound having, or the existence of compounds having the same molecular formula but different structural formula. Okay, then the first 3 alkanes, they do not form isomers. That is methane, ethane, and propane. So these 3 alkenes do not form isomers. So we begin forming isomers from butane. And isomers are formed using a method, a naming method known as IUPAC naming system. IUPAC are initials that stands for International Union of Pure and Applied Chemistry. And it follows some rules. It follows the following rules, or what we refer to as the guidelines. So if you want to name an isomer, you follow these steps. Step number 1, you have first to identify the longest continuous carbon chain so that you get the parent name. So you first look at the longest chain, and this longest chain, carbon chain that is, will give us the parent name. Second step, we are going to name or to number the longest chain from the end of the chain that is near the branches, so that the branch get the lowest number possible. So we might have different type of branches. For example, we might be having a halogen as a branch, an alkyl group as a branch. So we have to make sure that we start counting the number of carbon atoms from the end that we have that is near the branch, so that the branch will have the smallest number, or we shall give it the number that is the smallest. Then step number 3 is to determine the position, the number, and the type of the branch. Then we name these branches. For example, if it is an alkyl group, you can name it methyl, ethyl, propyl, butyl, and so on. If it is a halogen, you can name it fluoro, chloro. Maybe that is from the halogens. That is from fluorine, chlorine, bromine, iodine. This is where we get the names fluoro, chloro, bromo, iodo. That is from a halogen. This is when we have a branch of a halogen. So we name them according to the number of carbon chains that it is attached to the parent alkene. Then if we have more than one branch, we use the prefix. If we have 2, we use if we have 3, we use the prefix tri. If we have 4, we use the prefix tetra, penta for 5, hexa for 6, and so on. So if we have more than one, make sure you show or you name them. You use the prefix to name the branch. So for example 1, we have to name, we are given this isomer here, and we are told to name. So we have CH3, CH2, CH2, CH3. And from the steps or the rules or the guidelines that we have given, we start by identifying the longest carbon chain. And we can first start by writing this formula. We open this formula of the isomer. So we have 5 carbon atoms, 4, 5. The first one has 3 hydrogen atoms. The second one has 2 hydrogen atoms. The third one has 1 hydrogen atom and a branch of methyl group. So we have CH3 at carbon number 3, that is a branch. Then carbon number 4, we have a hydrogen and a hydrogen, and we have 3 hydrogens in carbon number 5. So if we have opened our structure like this, it will be easier for us to name it. So we have the parent name from 5 carbon atoms, that is pentane, pent meaning 5. Then at carbon number 3, we have a branch of methyl. So we have position, it is carbon number 3, and the name of the branch is methyl. Now with this one, we can name this isomer. So we start by giving the position of the branch, the name of the branch, and then the parent name. So for our isomer here, it will be 3 with that dash there, don't forget. So 3-methyl pentane. So that is the name of that isomer, and that is how we come up with that name. We look at example number 2. So we have how many carbon atoms? 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon atoms. So let us open this structure. 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms. The first one has 3 hydrogen atoms. The second one has 2. The third one has 1 and a branch of ethyl group. The fourth one has 2 hydrogens. 2 hydrogen for the fourth one, 2 for the sixth, and 3 for the seventh hydrogen for the 7th carbon atom. So now let us name this isomer. So the longest carbon chain, it's this one. It has 7 carbon atoms. So from 7 we have hept. So heptane. The position of the branch is at carbon number 3. So 3. Then the name of the branch is methyl. So how do we name this isomer? We have 3 for the position, methyl for the name of the branch, and now the parent name, heptane. So 3-methyl heptane. Then make sure that the name is in small letters, don't combine. So all the letters are in lowercase. So even the M here will be a small m. So let us look at example 3. Okay, so from our isomer, we have first to identify the longest carbon chain so that we can get the parent name. So the longest carbon chain has 4 carbon atoms. So we have 1, 2, 3, 4. Even if we decide to move with this carbon atom, we can count 1, 2, 3, 4. So also that one will have the longest carbon chain to give us butane. Also from this right side, we can count 1, 2, 3, 4. So that 1, 2 will also give us the butane. So all the sides, if we decide to count from any side, it will give us 4 carbon chains for the longest carbon atoms. So the parent name is butane. We have 2 branches, one at carbon number 2 and the other one at carbon number 3. So if we start naming now the branches, we have a methyl and a methyl. So we have 2 methyl, and we said if we have more than one, we use the prefix. So since it is a 2 branches, we use the prefix di. All right. So we have to start now giving the position of the branches. So we have 2, 3. So 2, 3. So we separate that one using a comma. Then di to show there are 2. Then methyl butane. So 2, 3 dimethyl butane gives the name of that isomer. Example 4. Let's identify the longest carbon chain. It has how many carbon atoms? So 1, 2, 3, 4, 5, and 6. So we have the longest carbon chain has 6 carbons. So this gives us the name hexane. So that the parent name is hexane. Position branch is at 2, at 1, at 2, and at 5. So those are the positions. Then the name of the branches, all of them are methyls. So we have to give the three, since they are the same, we use the prefix tri. So the name now will be 2, 5, 1. So 2,5,1 trimethyl hexane. So that is the name of that isomer. We look at example 5. We have an isomer with 1, 2, 3, 4, 4 4 carbon atoms, making the longest carbon chain. The parent name now will be butane. Okay, then the position of the branches, it is at carbon number 2 and at carbon number 3. But now for these two branches, they are different. So we have one, it is a halogen, the other one is an alkyl group. So we have to start naming the halogen. So the position of the halogen come first. So we have at position 2, we have a chlorine, so that will be chloro. Then at position 3, we have a methyl group. So now this one will be first name the halogen, so 2 chloro, then 3 methyl butane. Okay, so 2 chloro, 3 methyl butane. That is the name of that isomer. So note, when we have a halogen as a substitute or as a branch, it will always be named first, then the alkyl group. So make sure you start counting the carbon atoms from the side we have the halogen. So that marks the end of part 2. Let's meet again in the next lesson.